Let's talk about the very first topic in our security star, or star of security. And this is injections, right over here. And we're starting off with injections because these are the most common attacks. For the last number of years, out of all these techniques, this is the most common, the thing that leads to most financial loss, and I'd say about 50% of the time, if you're preventing against injections, you've covered a big chunk of improving security. So probably the most important topic, and it's also really fun to teach. So we're going to start off with this one. Now, injections means injecting code into another piece of code. And there's a couple ways that you can do this, but it's a big principle. The idea that we receive code that we didn't really want from a third party, a user or somebody else, and they're trying to mess with our code and change our code and perhaps do bad things. And like I said before, it's the most common attack. And one of the most famous injections is something called SQL injection. And these are two examples of SQL injections. But you know what? We're just looking at a piece of text right now. It doesn't really mean anything. Let's actually perform an SQL injection and see how it works. I'm going to be using pSQL, which is a database for Mac, but there's tons of other versions for Windows and Linux that you can use. It's essentially a graphical user interface to play around with your database. So I'm going to be using this, and I should have it open right here. As you see, I have two tables here, login and users. But for this exercise, let's just create a new table, and I already have created the SQL statement here. And again, if you're not 100% comfortable with SQL yet, then I cover that topic in my other course, so I do recommend you check that out. Or you can find some really good resources online for it. All I'm saying is I want to create a new table called SQL injection. It's going to have a column of ID and a column of email. If I click Run Query, there you go. If I refresh now, I see that we've created a new table called SQL injection. Now, there's nothing in this table, but we do have the ID and email column. So let's add a new row here. And I actually have them prepared over here. So we'll just do the insert into SQL injection. So we're going to insert into the table the email field. We're going to add LOL to it. So let's run that query. All right. And if we go back to our table, we see that we have a new row, an ID of 1, because I've set it up so it's just sequential. I'll just keep adding 2, 3, 4, 5, and then email of LOL. Now here's some SQL injection that we can do. And we want to do something like this. Let's say that we're updating this email field because the user just changed their email. So if let's say, update my email to something like this that we had from our table, and make sure I have a quote here. So what I've just entered is I've entered my value of my new email to have this piece of code. And you see that it's kind of highlighted everything instead of just being a string like it would have been if we did this. So by just modifying that piece of code like this, and make sure we have that quote, see how the colors change? What I'm saying is I have played around with this SQL statement and made it so that we update the values to an empty string, but then add the semicolon. We have another statement that drops the table users, or let's drop the table SQL injection. And then I end the statement with this line. and we don't need the quotes anymore. You see that it's been highlighted as if it's an SQL query. And we just simply do drop table SQL injection. If I click run query, and now I refresh. Whoa, did you see that? Our SQL injections table was just dropped. That's right. By just adding this piece of line, I was able to drop an entire table. So you can see how vicious that could be if I change this to login or users. I can drop the entire company's database. And that was simply because I entered this line. So even though we were expecting an email value, instead of providing an email, I just sent over this piece of code that essentially extended the SQL statement to drop the table. That is extremely dangerous. And you just witnessed one of the most common ways that websites get attacked. People just keep copy and pasting these lines in different inputs on websites and apps and see if it does anything and drops tables. And if we go back here, we also see this top one that says comma or 1 equals 1, again, dash dash, ignore everything after. Well, this can be put in a password field. For example, you have to log into a website and it says username and password. By adding this piece of line, you're saying in the password field, I'm expecting a password and I'll pass it on to my SQL statement. But instead, I'm going to just leave it an empty string and then say or 1 equals 1, which is true. So what that means is the database is going to check, hey, does this user exist and does this password match? But then because we're adding this or, saying, does this password match or does 1 equals 1? And returns the full user information and logs you in. And don't worry, I'm going to leave a fun exercise for you after this video so you can actually practice this on your own. That's SQL injection. And that happens with databases, but injections can happen anywhere. Anytime that a user has to input something, you can do injections. Let me show you another example. I've created over here a security exercise. And don't worry, I'm going to give you access to these files so you can play around with them. But I've created a very simple website. If you look at index.html, not much going on here. And we just have a button that on click sends information to the server. And I have a server set up as well. And don't worry, we're going to go over this. That is an Express server. And all we're doing is we have a GET request. So if I go to, let's start the server actually. Let's say npm start. We're listening to port 3000. So if I go to my Chrome browser, and let's open up localhost 3000, we see the hello world text because the endpoint is going to return hello world. And then we also have another endpoint that is a post request to secret. And I'm going to show you what that does. On the front end, we can open up the index.html file in our browser, which looks something like this. Very, very simple website. All I have is an input field and I can hit submit. Now this submit button, if we go back to the code, simply says send to server. We're going to grab the input.value and then I'm going to run it through this function that simply just adds the text to our web page. So again, if I type hello, submit, I see the text hello on the web page. And after we do that, we also do a fetch call, an API call to our server and send the secret through post method using json.stringify. We're sending the user input and as JSON. So we're sending it into the body. Once we click hello and open up the network tab, let's click again. We see that we're sending the secret to the backend. That's it. Nothing too crazy. If you're not too familiar with node servers, then again, I recommend you check out my other course. But you don't have to worry about too much about that. What we want to do here is practice another form of injection. We expect our users to play around and type in whatever they want. But what if a bad person comes and says, what if I just do a script tag here because we're adding it to HTML, right? We're just adding whatever we've gotten here to our HTML tag. So let's do this, script.alert. Boom. And then we're going to close that tab, this script tag. And now we hope to run this script in here. Let's see if that works. Nothing happens. We didn't even print anything. Now, if we go back to the code, we see that we're getting the input, and then we're using inner HTML, which is bad, as you can see here, to a p tag. But luckily for us, when scripts are injected into the DOM via script tags like we have, and we're using inner HTML, they're not actually run a time when they're injected because the DOM has already run and HTML is smart enough to say, yeah, I'm not going to run that. That sounds like a bad idea. Because scripts like this, which are called inline scripts, are only run at the time that the original page is parsed. So if I refresh this, that's not going to run. On the other hand, there is something we can do. Check this out. If we enter something like an image tag with a source of nothing really, just a slash, and because there's no source, this is going to error, we can do a on error event that comes standard with HTML. And in here, I can say alert, boom, and close that tag. If I do this, so an image tag that won't be able to fetch any image and it's going to have an on error of alert, boom. If I click submit, and let's open up the console, and unexpected end of input because we should use double quotes here. Let's try that again. Boom. We just ran a script that we injected into our browser. And this is because images are injected into the DOM at the time of encountering the image tag. And if the loading fails, like you can see over here, on error event, the handler is called. So what we've just done is we've injected a piece of code that is really, really bad into a website. So if you go around to websites and copy and paste this and try to submit it, and they don't have good security practices, you can inject whatever scripts you want into a website. Again, use this information wisely. Don't be bad with this information. We're using this as a way to learn how to prevent these sorts of attacks. So how do we prevent against this? Well, fairly simple. Instead of using this inner HTML, and that's why I say inner HTML is bad, don't use it, we want to use something like this. Let's comment that out. This creates a text node that is of input. So no matter what the input is, this create text node is going to convert it into just pure text and does something called sanitizing it. And because of this, we can just attach a text node to the p tag, and it doesn't matter how bad we are with our code, it's not going to do anything. Let me save and show you if that fixes it. So I'm going to submit again. Oh, and I have to refresh the page. Let me refresh. And let's try that again. This time around, I'm just going to copy and paste it. Again, same thing. If I click submit, all right, nothing happens. And this is just converted into text. That was pretty cool, right? All right, we've learned about injections. What can we do to fix them? Well, there's three main things that I want you to remember. One is to do something called sanitizing input. And that is something that we did with the input field on the website. The idea is called the whitelist philosophy. And what that means is for data validation or anything the user inputs, only allow the user to input data of your expected type. If you expect a text to be entered, an email to be entered, a phone number, make sure that you check using JavaScript that only those things are used. For example, with a phone number, make sure that it's only numbers that are, let's say, 10 digits. If it's not the proper type, discard it. So we're sanitizing it, we're cleaning it. And by sanitizing and cleaning it into a format that we want, using things like JavaScript, we make sure that no matter what, I can enter all these bad codes. It doesn't matter because I've already cleaned your input and it won't do anything to my system. And sanitization is typically performed by using either, like I said, a whitelist or a blacklist. So whitelist is good things that you can do. Blacklist is bad things that you shouldn't do. So some of the things that we can do is removing HTML tags while preserving perhaps the content or preserving only the textual content of a tag. Or prevent the user with a notification saying that, hey, you can't put that information in there, try again, put something in. The second point is something called parameterized query, and it's also called prepared statements. And it's a way to prevent SQL injections, like we saw. It precompiles an SQL statement so that all you need to supply are the parameters. Think of it as a function. If we go back to our example, instead of allowing the user to enter whatever they want, what we want to do is have a sort of function. So let me open up a tab here, a console tab, and you have a function, let's say that is SQL select statement. And within here, you give the name variable, the email, perhaps the ID variable. And inside of this function, you'd have something like if name equals number, then you can array it out, or you can say that if name doesn't have the length of this, or if name includes characters of this, you have control over what the user enters. Now, this is a big enough problem that there are a ton of really good solutions out there already. And they're called object relational mappers. That is, they provide these prepared statements, SQL statements for you, so that all you need to supply are the parameters. Just like I showed you, think of them as variables that need to be inserted into the statement for it to be executed. And this way, it prevents things that we done, like dropping that table and being able to enter whatever we want in an SQL statement. And one of the really good examples of this is connects.js that we use with our SmartBrain app, where we're able to use things like if we go to select, we're able to just give it parameters. All we say is connects.select, and we give it whatever parameters we need. Let's say we want to get the title, author, and year from the books table, and that's the only thing we can do. Connects takes care of actually building the SQL statement for us, but it parameterizes everything. So we can only provide the parameters to the statement. All right, so there you have it. Those are injections. You prevent those and you make sure that whatever the user inputs is something that your program expects, then you're going to avoid majority of the security issues that are out there. Like I said, injections are the number one cause of attacks on websites. So validate every last bit of user input using whitelists on the client side as well as the server, and never directly inject user content into anything. Again, user input should always be untrusted. The only thing that you can control is how you run your program, so you can modify any untrusted data into trusted data. I'll see you in the next one. Bye-bye.